Hello and welcome to another video. Today we have something a little bit different. It's still an ATX motherboard like we usually do, but this has an interesting fault. This has a broken off M.2 connector. I've never seen this before. I've never had to repair this. And if we have a good look with just my overhead camera, we can see where it is missing. And this is the connector that was on here. I've never repaired this, so we're going to figure out together, if my camera could focus, what to do and how we're going to proceed. I have no idea how something like this happens. So let's have a good look at the board and the connector if we can actually reuse this. So let's go under the microscope. So this comes from a viewer, this board, that sent it me over from the Netherlands. And yeah, this looks like it has been forcefully pulled off. The pads on the board all look fine, but the thing is, how is the M.2 going to look like? Like the actual connector itself. Let's have a look. It actually looks like all of the contacts are here. That would actually be awesome. Okay, there's a little bit of damage here, but I think that could be fine. Well then, let's because I've never done this, I don't really know what the best way to do it is. But first thing I would do is to clean all of these solder off of the board actually. So let's put leaded solder onto everything. Then wick everything off so that we can actually have a good look at what we're working with. So first we're mixing all of the non-leaded solder that is on this board with leaded solder and have a good amount of flux also connected to it. It's really difficult to solder around this area because there's so many connectors close to here where you could burn them and have melted plastic. But yeah, that looks fine so far. Let's see how well it wicks off of here. Let me get a different tip and let me rotate this board around so I can more easily access it. So let's take some solder wick. So let's wick all of this away. I really need thicker wick for this. This thin wick is great for most details, but doing like big connectors like this with this small wick is really not the tool you want. So far, the board actually wicks off pretty well. So this looks promising. The big thing that we're going to have a look out for is for the actual M.2 connector. If we can clean it off enough to get the pins to connect back on. And especially for like places like these here, where there is components very close to it. And almost everything is clean. That looks very good so far. Okay, let's then clean off the area after we've taken all of the old solder from here. Yeah, so some areas here cleaned off better than others. Like as you can see, these pins at the right didn't clean so nice. And these ones at the top also, but the lower ones we're not going to redo, but the top ones we definitely need. There's too much solder left there. Now it's clean. Let's see. Let's get another cloth in order to clean this off properly here. And we actually have a squeaky clean position. Now it looks nice. Now we actually got a prepared place here. All of the pins look fine. The big question is now, how well will the M.2 itself clean up? So, what I would want to do probably is I'm going to hold it with tweezers from one side and then apply solder and flux to all of the pins in order to clean them up. So I need to be careful to not melt the plastic too much here, or else the connector will probably not sit properly. I've never done this, to be fair. I've never had to replace an M.2, so this is new territory for me also. Okay, this doesn't work. This, yeah, that is awful. This does not want to clean up properly. Okay, it does kinda. Let's put a little bit more flux onto these places where it did not want to. I'm still thinking about how to actually put this on. The safest way would be to just solder each individual pin by hand. So place it on there, secure the ground, the anchor points, and then just solder each pin in. But a better way would probably be to just apply leaded solder to everything and then hot air this on, or like reflow it from the bottom. Something like that would probably be the better option. But like I said, I have never uh, done this, so I don't really know what would be better here. Okay, so let's see how well this connector sits on here and how accessible the pins will actually be, so that I can get an idea if we want to hot air this on or if we want to solder this. And I got to be honest, it actually sits better on here than I thought. Like, this side is definitely hand solderable. Let's see for the other side. Also, so I'm actually thinking about just soldering this pin by pin to be safe. Because on SIOs, for example, I also do it pin by pin, so that I can be sure that every pin is connected properly. And this is probably what we're going to do here as well. So this is going to take a while, but I think it will be the better option here. So what I like to do first is to secure the anchor points so that the connector doesn't move anymore. Kinda like that. One anchor point secured, and all of the pins still where they are supposed to be. And let's secure the other one, and then we go ahead, take a smaller, probably going to take a smaller solder iron tip, and then solder all of those in. Just like that. What would really help probably is to have a preheater here. Put this onto a preheater, preheat the board, and then connect all of the pins. We might still do that. I'm going to apply flux for now. Let's see how well these solder. So let me take a small tip that I have, and let's see if the heat transfer of it is enough to actually solder these pins on. So you can see this is a very small tip. And just by like the thickness of my solder, you can see how small these are. Yeah, some of these have a big ground plane attached to them. This one does not want to solder easily. This pin right here. The others weren't too hard, but this one refuses to solder up. Right there, it's soldered. Okay, to make this easier, I'm going to bust out the preheater. I'm going to let it preheat a little bit and make my life easier like that to get a good connection on every pin. So let me build this up on a preheater and then we will continue this hand soldering here. So the board had some time to cook now. A little bit different of a view now. Let's see if we now can get some good solder joints in here. It's definitely easier to solder, but we have a solder bridge right there. It might be that these two pins are actually bridged by themselves. So internally, so that that doesn't matter. But we definitely have to get the connection off of this ground pad here. It's a lot harder to solder while it's on the preheater because the board is suspended a lot higher and isn't fixed anymore. So let's see if I can get this proper here. Kind of like that. We're going to leave it for now like that. And we're going to later see if these two pins need to be separate or not. So this is going to be the hard part right now. Because these pins that we can see right here, these are basically protected by the DDR covers. So it's really hard to get my soldering iron properly into there. But we're going to try to solder each of these pins individually here without destroying anything. Another few pins down. The biggest problem right here is I cannot get my wrist supported properly in order to have a steady wrist because the preheater is very hot. I'm going to put on a glove onto my hand so I can actually rest my hand onto the preheater. This is also going to take some accuracy off of my hand, but it makes me that I can at least put down my hand properly and have less shakes. So the preheating definitely helped a bunch in order to get good connections here. Okay, that seems to be that the first side is soldered. That is actually a lot harder than I thought it is. But all of the pins currently look like they're attached. Let's see if we can get rid of this solder blob right here, just like I did on the end of the other one. Sorry that I'm so silent, that this probably mostly is like a skipped over. But this actually is harder than I believed it to be. So this is a constant reapplication of flux in order to get the solder to melt properly. Because the solder that I have right here just wants to stick to each other, doesn't want to stick to the pad properly and to the pin for whatever reason. So I will definitely just have to take off as much solder as I can from there to get it precisely like I want. There it is. That was hard. Okay, this is the harder side, mostly done. We're going to have a better look from the side onto it also. But for now, we're going to keep it like that. And we're going to move on to the other side. And we're going to try to solder that on. Have a good look what I just found. What the heck is this? While soldering the board, while going around, I just saw that this PCIe slot is completely mangled. Wow. Whoever has been working on here has destroyed this PCIe slot completely. Like, not completely, but to a pretty good point. Wow. We will have to have a look at this as well. But my god, that is bad. Oh man. Well, we're going to worry about that later. Let's first have a look at the M.2 and get this firstly done, and then we're going to have a look for the PCIe, what we can do there. These pins right here have so much mass to them. This is probably like 12 volts on ground here. And these just love to stick together. Like, I really don't know why this solder behaves so badly and at these points. It's just like as if my soldering tip isn't even on. That's kind of like how this behaves. Even though there's a good amount of flux, these pads could definitely connect the pins to the pads. And yeah. Yeah, I might need to go to those with a bigger soldering tip because this just won't do. And I might want to turn up the preheater a little bit for that area. But let's continue with the data lines here. Some of these pins just don't want to take any solder, and some just love to bridge instantly. Not a pleasant experience to solder this. I'm such an idiot. I'm fighting with these 3 pins for so long now. And now I know why they connect to each other so easily. Because they're all 3 the same pad. All of these 3 is 3 volts. So all of them are supposed to be connected. And that's why I cannot separate this easily. So we're just going to go with that. We're going to connect them all to each other and let it be. And now I think I'm done with this. This took so much longer than I thought to solder up properly. What means properly? In a way. Not the cleanest joints, but they will do, and nothing is shorted. There's one pin I'm not happy with that you can see. Let me see. Just get a little bit of reflow into that one. Just about that one. Let's see now again. Yeah, better. Okay, let's have a good look at the other side. And yeah, these look better. Okay. So this should be it for the connection here. Let's now take this off of the preheater and let it cool off, and I'm going to be cleaning it off in the meantime. So I've now cleaned it up, and it actually doesn't look too bad on this side. to be perfectly honest. Just the other side looks awful. Just a little speck of debris here. Get that off of here. Like, this side doesn't look too bad. This side is worse, but it should be fine. I got to be honest, if I would ever do this again, I would probably opt to hot air this in, because this wasn't a pleasant experience to solder these. Like, this was way harder than I believed it to be. And we have to do something about these capacitors for the PCIe line. Because, as you were able to see, the PCIe is destroyed from like 8x onwards. So this is how it's supposed to be. You can see the pins looking are locked into the side, and this is how this is. Like this pin, for example, right here. This one is supposed to be in there. Like, these pins are completely screwed. It's really hard to get into here with even a fine tweezer, because the space is so confined. And yeah, this goes all the way. You can see every time this pin is from there to here, it's broken. And like, look at this. Where are these pins? Like, this one is completely under the other. Like, how the heck does something like this happen? Like, what has been done here? Who like played with this or screwed with this? Yeah, this definitely needs a replacement of the PCIe, but we can make this work like it is, just a little bit differently. So what we can do is we can make this board work with less PCIe lanes. So what we can do is, let's use some of these capacitors, for example these ones here. So what we are going to do, in order to disable the later lanes for like the 16x for these pins all of here, we're going to be removing the capacitors, I would say up to here, and probably leave these ones behind, maybe even these ones. But let's remove all of these capacitors so that none of the signals can be shorted to each other and cause any harm, and that this can still be used just with less lanes. There's not going to be a high-end GPU in here that will use all of the lanes. So this shouldn't be a problem if we going to remove them. But I do not know what kind of effects this could have if you plug a GPU into here while all of these are shorted. So I rather just get rid of them and make sure that none of these signals can interfere with anything. So I now removed these capacitors. Let's clean that up, that area. So as you can see, no more short circuits through these, because these are now disconnected. The big question is now, can I still put a PCIe card into here? Because they are really mangled. I'm going to try to plug in a GPU that is sacrificial into here. And let's see. Yeah, they still connect. That is good. So I can still put it into here. And these shouldn't do anything. Also on the GPU side, they shouldn't do anything even if they are shorting, because there's no receiving of any of these. That is not a guarantee, but we will try it out like this. And this will probably either be an only X4 or X8 slot. We will see for that. So let's see if any of what we did actually works. So because of the amount of damage that this board has, I want to see for the resistances before plugging anything into here. So let's see right here for our usual checks. Let's go quickly over them. 3.3 volts not shorted, 5 VSP not shorted, 12 volts not shorted, 5 volts not shorted, 12 volts CPU not shorted, 12 volts into the phase, also not shorted. Okay, so I'm very interested in if this board boots. So let's see. We're going to use a normal CPU, so no APU this time. 1 stick of RAM. Going to be plugging in my sacrificial GPU that can very well die here. Let's put in a M.2 and see if it actually worked what we did here. And let's see then. Passive power consumption. That is very low. 70 milliamps is like the CPU is not being recognized. But let's hit that power button and see. Okay, it does work. 2.6 amps. 2.8, 3 amps. That looks fine. Let's see if we can get a picture on screen. 6 amps, that looks very good. So the power on procedure seems to be working here, the post. Big question is if we get an actual picture from this GPU or not, because of how messed up the PCIe slot is. Let's see, because it's stuck for quite some time now in this state. Let's see if we have a recognition on the keyboard, if this board is maybe already on or not. No, the board is not on. I have a keyboard plugged in and there's no numlock reaction. So this board is still trying to post. So interesting. 3.2 amps and stuck. Without any, let's take a different USB just to be sure, just to check. Yeah, still nothing. Okay, let's then turn this off once more. Let's take out the NVMe and let's replug the RAM that we have. And let's try without the NVMe to start this up. And we're going to go with lesser and lesser components and see if we can get anything to post and boot here. Because the power consumption looks good on this board. Like the way that the current is jumping up and down would tell me that this board's... Oh yeah, now it's on. It's actually on. Yep. The board has now booted. Question is now, why don't we get a video output? Let's turn this off. Let's replug this GPU a couple of times. In and out. So let's see if we can get, after a couple of times replugging it, if we can get a picture out of this. Yep, the bot is already on, but we're not posting. But do not get a video signal. This is bad. Yeah, this PCIe slot probably needs to be replaced. That's a bummer. I would have really thought that we could use it like in 4x mode or something like that. Can I disconnect some of these? I'm thinking about disconnecting some or more of the pins so that there's actually nothing shorting anymore. Like I have right now, where just pins are touching each other. Because it probably would be better if they are just not there. So I want to try out if this PCIe slot is actually already completely dead or not. So how I do that is with a riser, where I'm plugging the GPU into, that only uses X1 of the of the PCIe, so only the very first few lanes. So let's see if this can work with the GPU only plugged into X1 with PCIe, with the PCIe riser. Yeah, it can work. So the PCIe slot is not completely buggered, because we now have a picture. We just probably need to get those pins to not short to anything anymore. I will need to see if I can pry those pins out and have no shorts anymore. So let me see if I can pry these off under the microscope. So let's see if we can get these pins like broken off or something like that, in order for them to not be there anymore. Because they're already not connected anymore, because I took off those because I took out the PCIe capacitors. So all I would want to try is for these to not touch each other anymore. So I've been working on this board for over 2 hours now, and I've been doing a lot of work to this, and I've got it to a semi-working state. What I've done is I've cut a part of the PCIe. This board now works in X8 mode. I had to Dremel this out and then desolder all of the pins and cut them. And now the board works. The M.2 is recognized, as you can see, because it's in Windows. The GPU is recognized in X8 mode because the render test of GPU Z is running. You can see by the power consumption where we are at 11 amps. So we're going to cut this also. So we not going to overload my power supply. Whew, this was so much work. Let me show you under the microscope how that looks like. Like, don't get me wrong, this is a complete botch job. Like, the thing is, it isn't worth at all to do this to this board. Like, what this would need is a complete restoration of the first PCIe slot. Desoldering it completely, putting a new one in, putting those PCIe capacitors on back. But this board is not worth it. This is just a B450M A Pro from MSI. This is such a cheap board. My main goal was to make this functional. If I would have a soldering pot, I could actually do that. A soldering pot is really great for this. What you do is you have a big pot of solder that is liquefied, and all you do is you dip the board into that, unsoldering all of them at the same time, taking the whole slot out, putting a new slot in. It's like if everything goes smooth, that's like a 1-minute operation, and you have a brand new PCIe slot in there. But doing it manually, desoldering every single pin, and then clearing out every single hole is just, that's not worth for a board like this. If you have had like a brand new X870 board or something like that, that would definitely be something you could consider. But with the B450 budget board from MSI, that's nothing you should do. Like the things I do most of the time are like economically not reasonable, but this would be way beyond that. Let me show you how it looks under the microscope. And this is the cut PCIe slot. I did Dremel it right there, and then went ahead and basically not completely desoldered, because some are just cut, as you can see. There are just some remains of some of them, but I got rid of most of the stuff here, so that the board can sit, the GPU can sit in here. And yeah, you can see also the cut wasn't as clean as it could have been, but as you saw, it does work. Like, we still get X8 connection out of this, even though, as you can see, all of these are cut here, and this is just plastic that is melted a little bit, but the board is now safe to use, and you don't have to risk your GPU anymore. Like, there's nothing going to happen to this anymore. Nothing going to short like where it shouldn't. Everything is on place now, and these are in good condition for X8. Like, don't get me wrong, this is a complete botch job. But I'm not going to spend the time to put a new PCIe slot in here. And you were also able to see that our M.2 that we put into here also works, because it was in Windows and worked in there. Oh man. Leave me your comments what you think of the repair that we did here. What you would have done, or how you would have done it differently maybe. And yeah, I hope you, even though this video was just completely botched together out of a lot of soldering and then just jumping around, I hope you still enjoyed it and still learned something, and that this was something special. Yeah, let me know what you think in the comments about this botch job that I did here, and about this board in general. Thank you very much for watching. All of my tools, as always, are linked in the video description. This was Mainboard Medic. Thank you very much, and goodbye.